Ladies and gentlemen, number 2. All right, so using the data in Appendix 2, and I've written it down because I did not have a picture of it. You get the search, and in our current textbooks is the last column, and they're all in joules per Kelvin mole. That's the unit. We are going to calculate the standard enthalpy changes for the following reactions. And if we remember that delta S is equal to the sum of the standard entropies of standard entropies of the products minus the sum of the standard entropies of the reactants. Now, and as we're doing this, my recommendation, so we'll start with A, is I would write for the reaction. You don't have to write the whole thing out, but I would write products, SO2, minus reactants, S, RHOMBIC, rhombic, and O2. I would write those out. Right? Because we're doing this. So that's what this is right here, right? That's the first line. So, and again, if you want me to put it in there. All right, that's what we're doing. We're going to do that 3 times. So for SO2, we have 248.2 joules per mole Kelvin. Minus, I have 32.1 joules per mole Kelvin. Plus 205.2 joules per mole Kelvin. Right, remember, for entropy, everything has entropy, so it's not 0. And then you have the math. So you'd have your 248.2, right? And now, what's important here is that all these are 1s, right? Our coefficients are all 1s. So it's one of those, it's one of those, and one of those. Now that's important. All right. So for our reaction, if I do the math, I'm getting 10.9 joules per Kelvin mole. For B, same thing, products, so our reaction, entropy change of the reaction. Products would be magnesium oxide and carbon dioxide, all coefficient of 1. Reactants, magnesium carbonate. All right. So magnesium oxide was 27. Carbon dioxide's 213.8. Magnesium carbonate is 65.7. So S would be, if we do this math, I get 175.1. So that's B. C. We have the reaction. A little bit different now. So I have CO2 and H2O. Sorry, my finger took it. And we have what? 4 and 6, right? 4 and 6. All right, that's important. So our products minus the reactants, C2H6, ethylene, and O2. And we have 2 and 7. All right. So S standard of the reaction, 4 times Looks like it's 213.8. Plus 6 times H2O. Oh, I didn't look up H2O. H2O is H2O liquid. I think it's 70. Looks like it's 70. Ethylene is 229.2. And oxygen, O2, was 205.2. And so if we do this, looks like I'm going to get negative 619.6. Well, hopefully that works for you. If you have questions, reach out. Otherwise, we'll see you in the next problem.